Okay, can you hear me now?
Yeah, sure.
Okay, awesome.
Hi, Jeff.
Hi.
Hi, teacher.
Hello.
Hi, teacher.
Hi.
Hi, teacher.
Hello. How are you all today?
Good job.
Are you all enjoying the lockdown?
Oh, no.
All exercising or not at home? Huh?
Yeah.
No. Yeah, my hat.
Okay, we'll start, okay? So good morning, class. Before we go to the next part is force, mass, and acceleration.
There's so little of us here.
Yeah, Namana, it's okay. I don't know, I'm not sure where the rest are. I have Beatrice, Nicholas, Shaluk, and Tachu. So still have Wingan, Mehak. Mehak came in just now, right?
Yes.
Yeah.
Okay, never mind lah. We'll just continue first. Okay, so before we go to the new chapter, I just want to go through some of the questions that I uploaded that you all answered last week's class, okay? So I'm just going to share screen. I'm just going to go through some questions. Okay, so this was the question last week that I uploaded. Okay, so wait, let me just accept this. Some of your friends. Okay. Now everyone is here. There's Beatrice, Lohindra, Nicholas Koo, Sherlock, Tachu, Mehak, and Wingan. Okay. So, like I said earlier, I'm just going through last week's questions a little bit. Just some of it. So, let's look at this one. Okay. So, you're supposed to find the reaction force and the motion. Okay. So now, how do you do this? Anyone wants to explain how to do?
So can you repeat the question?
How to do question one. This was last week's work. So I just want to go through it and discuss. So do you all, how to do this? I'm given the weight. The weight is the force that is pulling it to the bottom.
Is it 20,000?
Yes. So the reaction force is the one opposite to the weight. And because the resultant force is 0, that means there is no net force. So driving force and air resistance is 6,000, 6,000. So they cancel out. So for resultant force to be 0, the reaction force has to be 20,000. Which means what is the motion? What would the motion be? Constant speed. Okay, steady speed. Not accelerating, not decelerating. So same thing here. So now I have weight 20,000, reaction force 20,000. So up and down balance. Even by looking at the arrow, you will know that for the up and down, the forces are the same. The left and right, the forces are unbalanced. So driving force, which is the thrust here, is 15,000. Air resistance and friction is 9,000. So what will the resultant force be?
6,000.
6,000. So the motion is
Accelerating.
Accelerating.
Accelerating. Okay, moving forward, acceleration. Okay, let's try the third one. Okay, resultant force is 0. So if my reaction force is 800, my weight will be 800 also. And my motion is,
800.
what will my motion be?
Constant speed.
Constant speed.
Constant speed.
Yeah, that's basically what they're asking for lah. Okay, and then I want to go to this one. Okay, this one. I have two pictures below. This is the graph, and this is the skydivers. This graph basically represents the skydivers. If you see, right, at the velocity A, B, and C, A to C, it's the velocity is increasing. That means the speed is increasing, which means when you first drop off the plane, you're going down like really quickly. So your speed is increasing, and then after a while, okay, you will come to a steady speed. This is your terminal velocity. After the air resistance and the weight is balanced out, after you have a huge fall, after speed increases really high, after a while you become steady because you have reached terminal velocity. Then what is this? Suddenly the speed drops. When
You
does
open
the
a
speed
parachute.
drop? Correct.
Yeah, when you open the parachute.
When you open the parachute, now there's a large surface area that that is exposed to the air particles around, which means what increases? What force increases?
Air resistance.
Air resistance. So because air resistance increases, your speed now decreases, and then now you move upwards. The parachute brings you upwards, so your speed drops. That's why it's a very like steep drop. Okay, it's a sharp drop, and then after that you will reach terminal velocity again. So your speed will be really slow. So the moment you open your parachute, right, by the time you come down, it takes a while because your speed is super slow, but it's terminal velocity. You're moving at steady speed, but it's just that it's very, very slow. Why is it very slow? Because, I mean, the good thing about it being very slow is so that you don't like fall and smash your face to the ground lah. You slowly go down and then you reach the bottom safely. Okay, any questions so far?
No, sir.
No? Okay, then we will continue with today's class. Okay, so for today's class, we are going to force, mass, and acceleration. Can you all see this, the slides, the new slides?
Yes.
Okay, so today we are looking at
Yes.
Newton's second law. Okay, please take down notes. So what we want to look at is before that we must remember, we want to look at where that acceleration can be positive or negative. If acceleration is positive, that means it's increasing in speed. If acceleration is negative, that means it is decelerating.
Decreasing.
Yeah, decreasing in speed. Same thing lah. Decreasing in speed means decelerating. Okay, and here Newton's second law is what we're going to look at today. Okay, and then we're going to try and use the formula, okay, by rearranging it and things like that. Okay, so I have a question. So now, which stone is harder to move and why? So I have a big stone with a string, and then I have a small stone with a string, and I've tied the stone similar way to the string to the stone. I've tied it a similar way. Which stone will be harder to move and why?
The big one.
Go on.
Because there will be more friction on the big one.
Okay, what else?
It's bigger.
And then heavier. The gravity pulls it down even more.
Okay, so
And the
bigger,
small one.
heavier, more friction. Okay, so the heavier something is, the harder it is to move. That's something that is very logical to us. But I have a large box filled with things, and then I have an empty box. Of course, the heavier one, which has stuff in it, will be difficult to move. Okay, so now we look at acceleration. Acceleration means the change in velocity. Please take that down. Acceleration means a change in velocity. Okay, that means my velocity is changing. My speed over time is changing. Velocity equals to speed over time. So my speed, the speed of a moving object over a period of time is changing. So that's where we see if it's accelerating or decelerating. Okay, please take that down. So
One.
acceleration basically means a change of velocity. Okay, and now, okay, if someone is accelerating at 20 meter per second, so this is acceleration. Acceleration means s square. Okay, so if someone is accelerating at 20 meter per second, what it means is, okay, what does 20 meter per second means is they are getting faster by 20 meters per second. So every second, they're getting faster by 20 meters. That's basically what the term means. Okay, so a car is moving at 10 meter per second. Let's say a situation, a car is moving at 10 meter per second. That's the velocity given. It starts to accelerate by 5 meters per second for 3 seconds. What is its final speed? Anyone wants to try? It starts moving at 10 meter per second. So that's the starting speed. And then it starts to accelerate by 5 meter per second for 3 seconds. So what do you think the final speed is? Or after that 3 second, what is the final speed?
Is it 25?
How do you get 25?
5 times 3, then add to the 10.
Correct. So 5 meter per second basically means that its speed increases by 5 meters for 3 seconds. So each second, 5 meters per second. The second also another 5 meter per second. The third second also 5 meter per second. So 5, 10, 15 meter per second in that 3 seconds. And then I add it to the starting speed, which is 10. So altogether, 25 meter per second is the car's final speed. Okay, anyone confused so far?
No, sir.
No? Okay.
No.
If I'm too fast, please stop me, okay? Okay, so because acceleration only means change in speed in my velocity, it is possible for an object to have a negative acceleration. Okay, for example, an acceleration of -5 would mean the object is slowing down by 5 meters per second. So just now increase for every second 5 meters, now it's decreasing by 5 meters per second. So this is what we call decelerating. Okay, so you want to note down that the opposite of acceleration is deceleration, which means negative acceleration equals to deceleration. That's basically what it says.
So teacher, you can't say like reversing or going back. You have to say deceleration.
It depends on what the situation is. If the car is slowing down, then you say deceleration. But if the car is moving backwards, then it's reversing. So for example, last week's work, right? The one that there were the 3 questions. Are you referring to that?
Yeah.
Yes.
Yeah. So that one, the car is moving, the force taking it to the back is much larger, correct? I think it was the 3rd question. So
Yes.
it's moving backwards. So it's reversing.
Okay, teacher.
Okay? That means the
Okay.
force pushing the car towards the back is much larger. So it's reversing. Because in that question, they didn't have any acceleration or speed. So you just talk about the motion. Motion means the movement of the car. So the movement will be backwards, reversing.
Okay, teacher. Thank you.
Okay. Okay. So acceleration equals to change in velocity, and the unit is meter per second per second. Okay, remember velocity is meter per second, acceleration is meter per second per second.
Good job.
Oops, sorry. Okay. Okay. So let's look at the next one. Okay, then so this is Newton's second law. Like I said earlier, we're looking at Newton's second law. Okay, so Newton's second law states that force equals to mass times acceleration. Okay, F is force, M is mass. Mass is usually in kg. Acceleration is my change in velocity lah. So I can draw this triangle. Okay, I would like you to take down Newton's second law. F equals to m times a, and then draw this triangle as well. F at the top and m and a at the bottom. This will help you with your formula lah. Okay, and then please write down the units as well. For force is newtons, for mass is kilograms, for acceleration is meter per second squared, or meter per second. Okay, so please take down F equals to ma. Make sure you write down that it's Newton's second law. So Newton's second law basically states that force is the product of mass and acceleration. And take down this triangle because this will help you with arranging the formula depending on whether they're asking force, what's the force, or what's the mass, or what's the acceleration. And then take down the units as well. Okay, anyone has any questions so far?
Nope.
No.
Nope.
Okay. Beatrice, are you okay? Can follow?
Yes.
Okay. Okay, so very quickly, I just want to look at the triangle here. Okay, so if let's say the question is asking what the force is, then it's mass times acceleration lah. So because force equals to mass times acceleration. If they're asking what is mass, then how do I calculate what mass is? How do I rearrange my formula? Mass equals to,
F of
Divided
A.
by a acceleration.
sorry?
Force divided by acceleration.
Correct. So mass is equals to force divided by acceleration. And acceleration would be?
Force divided by mass.
Yes, force divided by mass. Okay?
Yep.
Wing Yan, okay? Wing Yan can follow? Okay. Okay, so let's try some examples, okay? Find the force acting on an object with a mass of 10 kg and an acceleration of 5. So find the force. So let me call out. Okay, Tachu, how to do this?
Use the Newton's second law.
Okay, so what do I do? How do I calculate for force?
And mass times acceleration.
Mass what?
Mass times acceleration.
Okay, so what will you get? What will your answer be?
50.
50, okay, so I have mass of 10, acceleration of 5 meter per second. Okay, so F equals to ma, 10 times 5 is 50, and don't forget your unit, 50 Newton. Okay, second one, what is the acceleration of mass of 5 kg if the resultant force is 100 Newton? So I want to find what the acceleration is. So Wing Yan, can you try?
I'm sorry, Vishrena, can we go to the previous slide for like 1 second?
Okay, wait, let me just finish this.
Okay,
Let Wing Yan finish first. Okay, Wing, how do you do this? How do you find for acceleration?
Force divided by mass.
Okay, and what will you get? What's your unit? Sorry?
M per square. M per. Yeah.
M per second. Okay, meter per second squared. So you should get 20. Okay, previous slide. Okay. This one I'm a hack.
Yes, teacher.
Okay, done.
Okay, I'm done.
Okay.
Yes. Okay. Thank you.
Okay. Okay, so remember Newton's second law, force is mass times acceleration. I have the units there. Okay. So, okay, so that's basically pretty much it for this part. Anyone has any questions so far?
No, teacher.
No?
No,
No,
teacher.
teacher.
No, sir.
Okay. Just a moment. Okay, so this is on page 41 of your textbook, yeah? Page 41 and 42. Okay. Now, okay. Yeah, give me a moment. Okay, let's look at some questions. Okay. Now, I'm gonna open this page. Okay. Force, mass, and acceleration. A special Ferrari is fitted with a speedometer that records the speed of the car every second. The car accelerates as fast as possible from a standing start, and here are the results. Okay, so I have the time and then I have the velocity. Okay, very quickly, can everyone just plot a velocity time graph of these results? Make time the x-axis. Okay, quickly. Plot the graph. Once you have plotted the graph, take a picture and send in the group. I want to see. Okay, who's not done? Can you raise your hand on the chat? Okay. Keep going. Those who are done, please send a picture of your graph on the group chat. The graph starts from 0, yeah? So you have to make sure your graph starts from 0. Because 0 in this question, in this table, 0, 0 is also a point. Make sure your scales are right. So far I only received 1.
Okay, do we have to title the graph?
Yeah, title the graph. Can
Okay, sure.
make sure you have label your axis. Okay, where are the rest of the graphs?
Sure, I'm sending a picture
Okay.
now.
Just send it on Zoom group chat, Acha. Or
WhatsApp.
WhatsApp lah easier.
Ya lah, Nicholas.
Or
So
actually,
you-
but you see lah, if it's easier for you to put it on Zoom, then you put on Zoom lah. Whichever is easier for you. Will
Okay,
take lesser
the
time.
easiest is only send.
Haha, very funny, ah.
Correct or you ask Nicholas.
not really.
Okay, yeah, that's why I said not really. He just play game, right, Nicholas?
I forgot to name the graph.
Sorry? Oh, you
I've
just sent. Okay.
forgotten name the axis.
Okay, please label your axis and resend.
Okay, sure.
Hey, Nick, count the stars in the sky. Hey, Nick. Nick,
Okay, those when you label your axis, right, make sure you put x is time, y is velocity, and make sure you put the unit. So velocity is m per s and time is second. Once you have plotted the points, you draw a line across all the points.
Oh,
And your title, so make sure to include your title.
Teacher,
Graph
send the
of,
picture.
yeah, your title should be graph of velocity
Velocity
against time, y-axis against x-axis.
yeah, can be time against velocity. Yeah.
No, it has to be the other way around. Your y-axis against the x-axis.
Why? Yeah.
Because that's the rule when you write the graph title. You always write the one that the responding variable first.
Oh.
Okay. Those who are asked to add title, label, axis, draw the line, can you please do all of that and resend to me? Okay, Nicholas, okay. Who else is okay here? Okay, Nicholas, okay. Mehak also okay. Wingyan, yeah, can you please label your axis, like which one is velocity, which one is time? The x-axis is always the bottom one, the horizontal. Y is always the vertical.
Sure, so I need to send for you again.
Yeah, correct it and send it again to me.
Okay.
Shaluk, also correct your graph and send it back to me.
okay.
Put your title, your axis labeling. Tachu, okay, Ken?
That's the
Okay. Beatrice?
Yeah, working on it.
Okay.
I sent already.
Okay, let me see. Velocity against time. Yep. Lohindra's one, okay. Do you all have a class after this?
No.
No.
No, completely free.
Wait, what?
Mahek, answer early, Mahek. You answer 10 seconds late.
Sorry lah. Wanted to answer.
What are you, Mahek?
Okay. Next class we will do, while everyone is finishing the graph, I'll just say. Next class, we will try and finish off chapter 3. Okay. Chapter 3, there's 2 subtopics, but it's not very long.
Okay, sure.
Yeah.
Okay, sure.
I'm hoping to finish I mean, depending on how long the lockdown is, the plan is to finish until chapter 4. But that depends on how everything goes. Wingen, your title? Put the title. Okay, Shuluk's one, okay. Wingen, include the title and resend to me, please. Okay, Wingen's one, okay. One, two, three, four, five. Okay, we'll wait for one more and then we will continue with the other questions in this in this graph question.
Nicholas, go. Nicholas,
What?
do you want some toast for it?
No.
Okay.
Nice.
Okay, for those of y'all who are done, just look at these questions and yeah, think about the answers, and then we'll discuss it in a while. Beatrice, how are you going with your graph?
Oh, it's done. How do I send it to you?
WhatsApp, Ken?
Oh, okay.
Yeah. Okay, so is the acceleration constant?
No.
Okay, why not?
Why I spoke again when the mic was muted? Because it's
The graph is not
Because
straight.
the thing is,
it's
Ex-
constantly
It's
accelerating.
constant at the front. Then after that, it's not constant already.
Correct. So at the start, from right up to the 4th second, it's increasing, it's accelerating constantly. So like 5, 10, 15, 20. But after that, it is not accelerating constantly. So from the graph, why we say that it's not constant is because it's not a linear graph. For it to be a constant acceleration, it has to be a linear graph. Linear graph means it'll be a straight line. Okay?
Okay, sure.
Okay, next question. What is the change in velocity between 3 and 4 seconds? This is the same as acceleration between 3 and 4 seconds. What is the change in
5.
5 meter per second square.
correct? So 5 meter per second square. Okay. What is the acceleration between 7 and 8 seconds?
3.
3. Okay.
Oh, yeah.
Now, next question. Give at least 2 reasons why your answer to question 4 is less than the answer to question 3.
Because the
These are
velocity
constant.
yes,
It wasn't
Wow.
constant.
between 3 to 4 and 7.
is it higher between 3 and 4, and then when it's 7, 8, it is lower?
Because from 0 to 4 it was a constant. Then from 5 to 8 it was not constant, so it can change.
Okay, what else?
So you can go down to a question. Okay.
At 3 and 4, it is constant.
Okay, so 3 and 4, yes, constant acceleration. And then towards the back, it's not constant. It's already, the speed it increases is much
31 to
faster.
34 is not a very big difference.
Correct. Okay. Now, last one. Imagine that the car contained enough luggage to double the mass of the car. Sketch on your graph the new acceleration curve. Explain your answer. Okay, now before you sketch, you are doubling the mass. So do you think the acceleration will increase or decrease?
Increase.
Sorry,
Sorry,
increase
teacher,
or
what?
decrease?
Decrease.
If you double the mass of the car, that means you put more things in the car. Will it accelerate? The acceleration increase or decrease? Will it accelerate more or less?
Less.
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 So which means the
It's
acceleration is
heavier.
not going to be maybe instead of 5, 10, 15, 20, maybe
1, 3,
5, yeah,
6,
1,
9.
correct, or 5 go to 8, and then maybe go to 10, and then maybe go to 12. So the acceleration is not going to be steady, and it's not going to be as big, because when mass increases, your acceleration will decrease. Just like the stone just now, the heavier stone, it's harder to push. So how would you sketch on your graph? So sketch means you don't plot points, you just draw a line to denote the difference. So how would it be?
Do below it.
Below it, okay, yeah. Anything else?
Below what? Or
Yeah, below
The
what?
line is
Below the first graph.
Oh,
So it will be below that, because the acceleration is smaller.
then I put dotted lines.
Dotted lines. Why dotted lines?
Don't know, ask me to say again.
Okay, so your graph is going to be lesser below the graph that you drew. Okay, so can everyone plot and then resend to me? Plot in the same graph. Okay, but sorry, sketch in the same graph. So no points, but just draw a line. And send back to me your graph. I want to see.
is it below the
Below the what?
okay?
Below the line that you drew lah.
Yeah, then after that, are we supposed? I mean, like the line is supposed to be less than 30 or less than 25.
What do you mean? Okay, can you draw and then send to me? Then I'll see what you mean.
Okay.
Yeah, mine, I don't know correct or not.
Now when you send to me first, I check. Once you're done, send it to me, yeah? WhatsApp it to me.
Lohendra, Lohendra, Lohendra.
Shaluk, please shut up.
Rude.
Mehak, can you stop being rude?
Hey, shut up.
Okay, calm down, everyone. Now, I will send some feedback on your graph, then you do and resend to me, okay?
Okay, teacher.
So make the line curving or
Yeah, a bit more curvier.
okay.
Miss Rina,
Yes?
teacher,
Yes?
I still don't quite get what I was supposed to draw.
So you're supposed to sketch how you think the graph will look if the car was heavier. So if the car is heavier, right? Of course, it's not going to accelerate as much. It's going to move in a much lesser speed because the car is heavier. So in the graph that you have drawn, you draw another graph. You sketch, not plot. You just sketch how do you think that graph will look.
Okay.
Teacher, I've sent it to you.
Okay, let me check. Now, when you draw your line, right, make sure you don't like try and color it. And this is not art class. You just draw one line and then that's it. Don't like shade and shade and shade. Okay. Let's see. Lohendra, okay. Beatrice, okay. Mehak, okay. Wingyan, I'm still waiting for yours. Shaluk, okay. Nicholas, okay. Tachu, so far, okay?
Yes, teacher.
Okay.
Guys, are you aware that you guys are texting in the chat?
Yes, I am.
Okay, guys, mute yourself, please. Thank you.
Yes, I am.
Okay, do y'all have any questions on today's class?
Nope.
No, teacher.
No, teacher.
Lohendra, you're always lagging, you know. What?
No, teacher.
Okay.
Lag.
Okay, so I will upload some questions on Edmodo, and then
Sure, no need question on.
you'll answer it, okay?
So when is the deadline?
When is the deadline? Since you all got no class, I will put the deadline today lah.
No, no, no.
You.
Teacher,
Why?
teacher, please, teacher. If
Okay, the deadline will be, today is Thursday, Friday lah, tomorrow. Okay.
okay, teacher.
So yeah, I'll upload the questions now. So yeah, please attempt it and then send. I think it will be in the assignment section. Then you send it back
Okay,
to me. Okay. So that is all
Okay.
for today's class. I'll see you all in the next class. Okay.